series, and then we'll be stopped at some point. So in this particular set of classes, we are going to be, talking more about statistics, doing a lot of things. And then I must say something that this series of lessons are being created for students basically. Um, no, let me start again. Hi, what's up, everybody? How are you doing today? Welcome back to this YouTube channel. I hope you're doing okay. It's been a while for real. Yeah, so in this lesson, we're talking about statistics. We're going to be having a series of lessons, a lot of them, to be honest. And then they'll be talking about, in them, looking at statistics. We started statistics a while ago, but then we want to like continue with that, right now. And the thing is, the classes are being, no, statistics generally, like, classes are going to be useful for like different people in different fields as long as you are doing things related to stat. But the specific thing that we are doing with this series is to aid the econometrics understanding of students in the future because students need to understand statistics now as for them to be able to apply them in econometrics, right? So you're going to start from the like really simple things. In the previous lessons, or maybe in the first lesson in this particular series, we introduced ourselves to the concept of statistics, right? So being a science that deals with data, right? A science that deals with the collection of data, the organization of data, the presentation of data, the analysis of data, right? In order to obtain valid conclusions, right, that could be used to make informed decisions. So, for example, if you're a business person, you want to know how many sales are you making per day, right? What's your revenue last month? What has the revenue been in the last 12 months? What's your profit? So you need those figures to be able to make projections, to be able to see how well you're doing. So statistics is basically about numbers. It's basically about data, right? So if you want to do data science, also be a data scientist, or you want to be data analytics, or I don't know what exactly those people are called, right? So you need the understanding of statistics to a very, very large degree. All right, and then there are branches. There are two major branches of statistics. So you have the descriptive statistics that is just basically referring to the summary of the unique features of a particular data without making reference to the population, right? So in statistics, you have samples and then you have populations. Now, population is just um, talking about population, otherwise known as the universe, right? It's talking about the entire data set of a given variable. And a variable on its own, from your understanding of mathematics, a variable is any measure that can take on any value, a measure that can take on any value. So let's say we're talking about the age of people in Nigeria, right? So the age of people in Nigeria, as at this point in time, our population is estimated to be around 220 million people, right? So the age of people in Nigeria would then be the age of the 220 million people. So that would be the population of ages in Nigeria, right? Since that's our estimated figure. But if you want to do maybe an analysis and then you need to like use age of people in Nigeria, are you really going to start looking for the ages of the 220 million people? Is impractical, right? Except you have data set somewhere. Even that too is kind of somehow. So it's kind of impractical. Then even if you get the entire data, it is like it can be too much for you to use. Like, what exactly do you need all that kind of data set for, right? So it might be too costly to get, and so on and so forth, right? So as a result of that, what you can now do as an individual is to like draw a sample. So a sample is an extract from a population data set, an extract. So what you can just do as a Nigerian is okay, go to some states, maybe just in order to like make it fairly distributed, go to some states in this six geopolitical zones in Nigeria. So you go to the southwest, the southeast, you go to two states, like ask for the ages of people there, go to the southeast, like you understand? So just randomly, like just go like that at the end of the day. So whenever you are able to come up with, it's now going to be a sample. Now, if different people should carry that exercise, they're going to get different samples, right? And then, so if um, your sample is correct, so not correct, like if it is reflective of your population. So let's say in Nigeria, um, people that the age distribution of 18 to 24 years or 18 to 30 years happens to be the highest in Nigeria. Those that are within 18 to 24 years are the highest in Nigeria in number, right? So maybe 100 million people, maybe realistically, right? So whatever sample that you're picking, whatever sample that you've generated must be reflective of what is in Nigeria. So let's say you picked about 1,000, like you asked about 1,000 people for their ages. So by the time you are analyzing that data, it must also show that those within the age bracket of 18 to 24 are the highest, like have the how would I even put it now? Okay, have the highest population in Nigeria. So let's put it that way. So your data set must show that. So your data set is not going to be showing that people within the age of 80 to 100 are are the ones that you have mostly in Nigeria, because that is not reflective of the entire population, right? So if you are carrying out a descriptive statistics, like you don't really make reference to like the Nigeria's population. So you just look at your sample that you've taken, then you begin to describe it. So you begin to talk about okay, the mode of the data, the mean, standard deviation, what are the things that you can observe, what is the lowest number, what is the highest number, get your range. So you are just basically talking about the unique features of that data set. You are not making reference, to whatever the population data sets may be or may have been, right? So that's about descriptive statistics. So the other branch of statistics is inferential statistics, right? So that's a branch of statistics, that draws conclusion from the sample to talk about the population, right? So you, like the example I gave, so from your sample now, we've seen that okay, 18 to 24 years old are more than any other person. So whatever you are drawing from there, is it reflective of what is in the population? If you go and check the entire number of people in Nigeria. So when you begin to like make reference from sample to the population um, data set, then that means what you're doing now is inferential statistics. So these are things that you're going to be learning in due course, right? It's not hard, but I must warn you that there are a lot of formulas, right, in statistics, but that's fine. So that's just that about that. And then you have different types of variables. I'm just trying to like summarize all of these things. You have the quantitative variables and the qualitative variables, right? The other quantitative variables, you have your what do you call it now? Your discrete variables and your continuous variables, and on. We've said those things in our first lesson. So um, that's just give us like a preview of what statistics is all about before we then begin talking about what we have to talk about today. So in today's lesson, we're talking about frequency distribution, otherwise known as frequency table. So what does frequency mean, right? So frequency is just talking about the number of times an occurrence, is happening or is taking place. The number of times that an occurrence is taking place, or in statistics for real, the number of times that an observation is occurring, right? So if you're looking at the scores of students, so how many students scored 40 over 50, right? How many students scored 50, 50? How many students scored 0? So what you're trying to like look for is the frequency there. All right. So what then is now a frequency distribution? So a frequency distribution is a table that shows the orderly arrangement of observations or data sets with their corresponding frequency. It's a table, so that's where you kind of start from, right? That shows the orderly arrangement. So orderly, it could be, or you could say that shows the array, all right, of a data set, right? So you can, with their corresponding frequencies, yes. So it may be from the lowest number to the highest number. It may be from the highest number to the lowest number. Whatever it is you're doing, just make sure that it is, orderly. So that's what a frequency table is. And for us to be able to construct a frequency table, we must know about a few things. Number one, you must know about what we call the class interval. All right, class interval. So class interval is a range of numbers that divides a data set into different categories. The range of numbers that divides a data set into different categories. So now let's give an example. So let's say we are talking about, let's draw a frequency distribution. So I think I have a simple example here. So we have weight, right, and then we have frequency. So the first one is weight is in kilogram. So you have 50, 56, and then you have 60. And the frequency here, 6 to, what am I doing? So 6, 2, and 3. 6 plus 2, 9, 8. So this is 11. What we've done here is what we call a frequency distribution. So this is a frequency distribution. But the data is ungrouped in the sense that, okay, let me give you an example of a group data. Now for a group data, it's still the same weight. So you use group data when your data set is large. So you just kind of classify some things together. Right, so that's what group data is talking about. Let me just write F there. All right, so here, 51 to 55, 51 to 55, and we have 56 to 60. 8, 4. So it can be more than this, but I've just made this kind of simple, not to waste our time. So this is a frequency distribution, this is another frequency distribution. Here, this is a frequency distribution of an ungrouped data, right? Because we just have one numbers and their corresponding frequencies. But here, this is a frequency distribution of a grouped data, right? So that means in the first one, 5155 is what we call the class interval, the range of numbers that divides a large data set into different categories. So these are categories and categories. So if you're 51, 52, 53, up to 55, you're in this category, 56 on and on and on and on to 60, you're in that category. So that's that about class intervals. Just a range of numbers that classifies a data set into different categories, so that divides the data set into different categories. And frequency distribution, we've defined it already. So now that we've known class interval, what is the other thing that we should know? The class boundary. So the class boundary is like the class interval, just that you deduct 0.5 by rule from the lower class interval, and then you add 0.5 to the higher class interval. All right, so you have the lower class interval and then the upper class interval. So which one is the lower class interval? This is an interval. So this number here is the lower class interval. This number here is the this number here is the lower class limit, like lower class limit. This number here is the lower class limit as well. Then this one is the upper class limit. This one is upper class. So you have lower class limit, then you have upper class limit in your interval. So lower, upper at the end of the day. So for you to get your class boundary, so what you just have to do, you don't do class boundary for on group data. So remove 0.5 from this, add 0.5 to this. That's just 0. So the first class interval is going to be 50.5 to 50. The first class boundary actually to this, and then the second class boundary is going to be 55, 55.5 to 60.5. All right, and then that's all. So the rule is that any number, because I have 55.5 and you have 55.5 here, so any number that falls below 55.5 is classified here up to 55.5 itself. But as long as it is above 55.5, then you classify it in the subsequent class interval. Since you have 55.5 here, 55.5 here, then there are rules to drawing your intervals, right? The differences have to be the same. No, class boundary. I keep mixing these things up. So this is your class boundary, right? So for class intervals in the beginning, there's a rule, right? Differences should be the same, and just to make your work easy, so just ensure that your differences are the same. So for example, 55 minus 51 is going to give us 4. 60 minus 56 is still going to give us 4, right? And then if you continue, the next one is going to be 61 to 65, on and on, like that. So here, since you're talking about class boundary, this one is now your lower class boundary. This is your upper class boundary for this particular class. Lower class boundary, upper class boundary for this particular class. So that's just it. So add 0.5 to the upper class limit, right, of your class interval. So you get the upper class boundary, and then subtract 0.5 from, and then you get your lower class boundary. So the next thing that we have to talk about is the class size. So how do you get your class size, right? So the class size is basically the difference between the upper class boundary and the lower class boundary. So in this, I've been talking about, this is the thing I'm talking about now. The first one started with our class intervals, second one started talking about our class boundary, then I'm talking about our class size. So class size is the difference between your upper class boundary and your lower class boundary. So when we do that, 55.5 minus 50.5, that's 5. 60.5 minus 55.5, that's 5, right? So these things are needed for further statistical analysis. So when we start to do mean, median of a group data, so you are going to see the application of all of these things. So what is really important is the difference between your class boundaries. Otherwise, talking about our class size. Okay, so the more you practice questions, the more these things are actually going to stick. It's not hard. And then finally, we talk about our class mark. So how do you get a class mark? The class mark is the midpoint of the class interval, not the class boundary. The class mark is the midpoint of the class interval. So class mark for group data is denoted as X. So if I want to find a class mark of this, class mark, so I'm just going to do 51 plus 55 divided by 2. So we have 106, right, divided by 2, and that's going to give us 53, right? So we do the class mark for this guy too. So this is going to be 116, right, divided by 2, which is going to be, is that not 58? So that will be 58. So the second one, what is it? 56 plus 60 divided by 2. That's going to give us 58. So the difference here is 5. So what you notice is that even if there was a third one, so let's say there was a third one, the difference between all of them is going to be 5. So you have 61 to 65. When you add this up, it's going to give us 126. So 126 divided by 2 is going to give us 63. So which is 63. So that's how you keep having it, like plus 5 plus 5 plus 5. Right? As long as what you've done. As long as your class intervals, right, have even, have the same, differences, across board. And then there is something that we call the open class interval. So what's an example of an open class interval? So you could have 65 plus. So that means 65 and above. So that's an example of an open class interval. So in case you hear it, the open class interval is not hard, right? So that's just how simple it is. So I believe that you guys are, enjoying yourselves. So we then have, don't worry, the class will soon end. Right? We then have rules for constructing a frequency distribution or rules for constructing a frequency table. So what are those? What are those rules? So you could be given a data set, like an assignment that I think we have in this lesson. Be given a data set, right? So after having that data set, so how do you make a frequency table from it? So the thing that you should know, number one, look for the lowest value, right? So rules of what do you call it now? Frequency distribution. So number one, look for the lower value. Number two, look for the the lowest value rather. Look for the highest value, right? Then find the range. Range is always different between the highest value and lowest value, and then find um, um, a suitable class interval, right? That you can then apply, to be able to generate your frequency um, distribution. So we're going to have an example now. As we're here now, construct a frequency FD. I just use FD to denote frequency distribution. I don't want to write any things. So construct a FD with scores of a cricketer during the season matches. So 10, 23, 65, 0, 1, 17, 34, 33, 21, and 0. 24, 47, 2, 21, and 53. 10, 17, 1, 5, 6, and 3. So the first thing, based on our rule, I think I should add an additional rule though, and the additional rule is count all the numbers, right? So how can we easily do that? I need to be counting one after the other. So I just need to know how many numbers are on this column, 1, 2, right? So how many rows do we have? 1, 2 as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if this is 2, this up is 10, then that means I have 20 numbers. So 5 here, 5 here, that's 10. 5 here, 5 here, that's 20. So be sure of those numbers because that means the sum of your frequency must give you 20 in this particular context. So what's our lowest number? I'm just going to go, okay, lowest number. From the look of it, you have 0, right? Then highest number. What's the highest number? 65. Is there more than 65? 78. Highest number is 78. So our range equals 78 minus 0, which is 78. Alright, so we are going between 0 and 78, right? Now look at the numbers really. Look at the differences. You have 10, 23, you have 17, you have 10, you have something that is 20 something, you have something that is 30 something, you have a 40 something. There is no 50 something, no 60 something, no 50 something. There's a 60 something, there's a 70 something. Alright. So what scale can we use? Right, I will capture 0, I will capture 78, and then we'll capture all of these numbers as well. So we can decide to use a 0 to 5, right? 0 to 5. So 0 to 5 is not 5 numbers. So 0 to 5 is 0, 1, 2, 3, 4, 5. That's 6. So 78 divided by 6, that should give us 13. Right? So if you want to have 6 numbers in each class interval, right? And so 13 times 6, that's 7. So that we are going to be having 13 different class intervals. But I don't think I want mine to be that long. Someone else will say, okay, let me use 0 to 9. We are using 0 because the lowest number is 0. 0 to 9 means 10 numbers. I have 78 numbers. No, I have 20 numbers, right? So, and then I have 10, 20, 30, something, whatever like that. So, 0 to 9. And I'm going to 78. So, 78 divided by 10, that's 7.8. Right? So, that's approximately 8. So, I'm going to be having 8 class intervals. I think I'll work with that. Right? So that's not too long. Right, so we can just do this. So I'm going to have what are we doing? Scores. So you have scores, right? You have their frequency. Well, let me do a tally. Okay, scores, all right, and tally, then a frequency. Um, so I want to use this 0 to 9, right? So the next number is going to be 10 to is that 9 minus 0? That's 9, right? So 10 to 19. Does it make sense? 0 plus 10 is 10, 9 plus 10 is 19. Okay. 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. So 9 minus 0, 9, 19 minus 10, 9, 29 minus 29, 39 minus 39. See? And look at all of these parts too. Differences 10 minus 0, 10, 20 minus 0, 10, 10, 10, 10, 10. Then here, 19 minus 9, 10, 29 minus 19, 10, 10, 10, 10. So what we have done is good. Alright, so we have this. And something I'm trying to like watch out for, just to make the whole thing easy for you to also construct. Now between 0 to 9, how many numbers do we have? We have 0 here, 0, comma. This just to make things easy. 0, 0. We have 0 again, comma. We have 0. We have 0. No? So you can just tick this to make it easy. Then next one, you have 1. So you have 1 here. You have 1 here. So 1, 1, comma. What else do you have that is between 0 to 9? Okay, nothing here. We have a 2 here. We have 3. We have 2, comma. We have 3. We have 5. We have 6. 5. We have 6. Alright, so how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5. 1, 2, 3. So we have 8. Did I change numbers? 10, 17 to 1. Oh, that is 56 though. Wait. 1, 2, 3, 4, 5, 6. This is meant to be 56. But it's okay. It's okay. So that means we actually have 21 numbers. It's fine. It's going to contain the whole thing. So our total number is 21. It's meant to be 56. But it's fine. So 10 to 19. 10 is here. So 10, comma, is there 10? Is there anything? I have 17. But before 17, I have another 10 here. 10. Then I have a 17. Is a 17. 10 to 19. Anything else? 10 to 19, 10 to 19, nothing. So 1, 2, 3. That's 3 numbers. Alright, then 20 to 29. I have 21. 21, comma. There's 21 here. 21, comma. Then is there any 20 here again? 23, 24, 23, 24. So 1, 2, 3, 4. I have 4. 30 to 39. Is there any 30 here? There's no 30 here. So I have 33, 34, 33, 34. 1, 2, just 2. Is there any 30? 30, 30, 30, no 30. So how about 40 something? So I have just 1. 47, 1. 50 to 59. The only thing that should, okay, 53 here. 53. So I have 53. That's 53. 1, 1. 60 to 69. This is gone, this is gone, this is gone. I think I've written 47. This is gone. So we picked everything here actually. This is gone, this is gone. 60 to 69. I only have 65 in this thing and 78. So 65, 1, 78, 1. So let me sum up the frequency. 8 plus 3 is 11, plus 4, 15, plus 2, 17, 17 plus 5 is 21. So what we've done is, right. So this is an easy way to work this out. But the thing is that at the end of the day, your frequency table, right, should only have like would typically have scores and frequency. So which means I'm either supposed to erase this, right? Like erase this middle. This middle is just to guide you, right? But what is majorly needed on your frequency table is your scores and then the frequency. But all this that we've done is to guide us. So if for example now you're asked like calculate the percentage of scores that falls above that's at least 40. So let's say we have a question. Calculate percentage of scores above 40. So what are we doing? Number of scores above 40 over total frequency. So number of scores, percentage of scores above 40. Number of scores above 40 greater than 40. Number of scores greater than 40. Please in the exam it should be number, please. No, number over total frequency. Frequency times 100. So what's the number of scores? So it's easy. Just come and check from what we've done here. You have a 47. So from 47 down, what's the frequency? 1 plus 1 plus 1 plus 1, that's 4. So you have 4 over a total frequency of 21 multiplied by 100. So whatever that gives you is your answer. Yeah, so that's about that. So I hope you understand the whole thing about frequency table. So now let's get our assignments and then that'll be all for this lesson. Yeah. I know. Teach you very simple things and give you very hard assignments. I know. There's nothing hard in the assignment, it's just a combination of the things that you've been learning in this lesson so far. Alright, so in your assignment, the final scores of 50 students on a FEM 204 course are given below. It's a course, like it's actually a course, a start course. So you have all of these scores, so there are 15 number, but count to verify. So again, what's the style? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, and it's complete up to this end. So 10 times 5 is 50. So number one, I'm using a class interval of, you've been giving your class interval, usually be giving your class intervals. So except you have to construct a class interval by yourself, which the question is eventually going to state. So using class interval of 55 to 59, so which means the lowest score you're starting from is 55, it's not 0, it doesn't have to be 0 necessarily. So A, construct the frequency table. B, find the top 5 grades. Then C, if you use the method that I taught you, where we're listing those cricket scores, and it's going to be very, very easy to find the top 5 grades. Now find the percentage of students who scored higher than 55 but not higher than 85. So they got more than 55 but they didn't score higher than 85. So literally it's telling to find range of people who are between 55, it says lesser than the score x, where x is lesser or equal to is 5. So that's what you're looking for. For those that understand that from inequality, I think higher than 55. Okay. So the last one, it says find the lower class limits and the upper class boundary of the first class. So when you've done the whole thing, so there's going to be a first class. So find the lower class limits of that first class and the upper class boundary. So that's about that. See you in the next lesson when we shall be talking about frequency polygon and histogram. Thank you very much. Bye.